Hi guys. Okay, so today we want to look at degrees and radians. Now before we get into that, we want to make sure we know how to use our calculator. So we're going to start with the TI calculator and we're going to evaluate some trig values. We are going to, for our purposes, always round our answers to 4 digits after the decimal unless you're told otherwise. Okay, the first thing I want to tell you about your calculator should always be in radian mode. It should always be in radian mode. Okay, so when you go to your calculator, notice up here it says radian. If it's not in radians, you can click here and it'll change to degrees or radians. Okay, makes it nice and easy. We want to stay in radian mode. Now there's a trig button here next to the 7. It says trig. And the first question we want to do, oh, see, you can see that this jumps. Yeah, it's kind of like playing whack-a-mole on this. This happens in the classroom too with the TI-Nspire software. Whenever the TI-Nspire software is open, it's like playing whack-a-mole, trying to get the trig things. So I apologize for that. Your calculators, it won't jump like that. We want to find the sine of 2 pi over 3. So it's the sine, and then I'm going to put in my fraction template, 2, and pi is down here on the bottom left next to the h. It pops up a little menu. We put in pi, and my 2 didn't go in, so I'm going to put my 2 in front there, and I'm going to arrow down 3 and hit enter. And there we have 0.866025. And we were instructed to write this with 4 digits after the decimal, so we would write 0.8660. And yes, that 0 is necessary. Do not drop that off. Okay, now let's try the cosine of 7 pi over 5. So I go back here, I go to my trig menu, cosine. And again, I want a fraction template, and it's 7, and we use the pi over, and now it's 5. Now notice both of these values that we figured out. So now we have negative 0.309017. Both of these trig functions that we did, we were taking the sine of 2 pi over 3, which is a radian angle, 2 pi over 3. And then we did the cosine of 7 pi over 5, which is also an angle in radian measure. So being in radian mode made sense. So let's write this answer down, negative 0.3090. Now notice this next one here, tan of 3. There's no pi in that. So some students look at that and say, that's not in radians. Yes, it is. If there's no degree symbol, it is a radian measure. That is the tangent of 3 radians. If it's a degree angle, there will be a degree symbol, just like an E over here or an F. Those angles are degrees because they have the degree symbol. So when we want to find the tangent of 3 radians, we're just going to go to our trig menu. We're going to press tangent and 3 and hit enter. And there we go. Negative 0.142547. So we're going to write down negative 0.1425. Okay. Now, cosecant of 9 pi over 8. Cosecant is a different function. It's not one of our normal 3 trig functions, but we like this on our TI-Nspire calculator. We have the reciprocal functions cosecant, secant, and cotangent, so it is already programmed in there. So we can do control and get our fraction template. 9, the pi is down here again. Choose our pi over 8, and we hit enter. And there we go, negative 2.61313. And I'm going to go back here and we're going to write that down, negative 2.6131. Now, before I go to the degree ones, just in case you do not have access to a TI-Nspire calculator and you haven't found an app for your cell phone that does this, and remember we said you can use free graphing app on an iOS phone, an Apple phone, iPhone, or you can use Algeo, ALGEO, on an Android phone. They work great. There is also this website. So I'm going to come back here because we haven't done any degree ones yet. So I'm going to go back to my calculator, cosine for 32.4 degrees. Now, yes, my calculator is still in radian mode. I am not going to change that. I'm going to do trig I'm going to go to cosine, and I'm going to type it in just like it is on paper, 32.4. And then over here on the bottom right next to the G, you see a question mark, an exclamation point. If I choose that, there's a degree symbol. It will now tell me the cosine of 32.4 degrees. And that would be 0.844328, which means my answer to 4 digits after the decimal is 0.8443. And if I want to do the secant of a negative angle, I go to my trig, I go to secant, and it's the negation of 125.2, and don't forget the degree symbol. Anytime you're dealing with an angle in degrees, you have to write or type the degree symbol. It is not optional. So this answer is negative 1.7348. Okay, now we talked a little bit, we were using the words degrees and radians. So let's look at what is radian measure. Remember the unit circle. The unit circle is a circle with the center at the origin, and the radius is 1. So if the radius of the unit circle is 1, what is the circumference of that circle? Now remember, any circle has a circumference of 2 pi r. But if the radius is 1, this just becomes 2 pi. So the distance all around this circle is 2 pi. But we also know that if we rotate all around that circle, that's 360 degrees. So we know that 360 degrees is really the same as 2 pi radians. Now, if 360 degrees is 2 pi, 180 degrees, notice how to get from 360 to 180, I divide by 2. Well, if I divide 2 pi by 2, I just get pi. So 180 degrees is pi. Now, if I divide by 2 again, 180 divided by 2 is 90 degrees. That's pi over 2. Okay? And these are really important measures. When you rotate around this circle, 0 degrees is 0 radians. 90 degrees is pi over 2 radians. 180 degrees is pi radians. 270 degrees is 3 pi over 2 radians, and all the way around is 2 pi. So these are really important measures. Pi over 2, pi, 3 pi over 2, and 2 pi. Now, not only are those 5 important, so are 30 degrees, 45 degrees, and 60 degrees. They're so important. I'm going to tell you right here. 30 degrees is pi over 6, and we're going to prove this in a few minutes. And 45 degrees is pi over 4, and 60 degrees is pi over 3. These particular angle changes between degrees and radians for these angles are so important. You should just know them. You should not have to stop and think about how many radians is 30 degrees. 60 degrees in radians is pi over 3. You shouldn't have to think about it and compute it. You should just know it, okay? Because you're going to use them so often, especially if you go any further in math. Okay, how can we change between degree measure and radian measure? If we have an angle already in degrees, to change it to radians, we multiply by pi radians over 180 degrees. Now remember, 180 degrees is pi radians. So that's really 1 that we're multiplying by. So 30 degrees times pi over 180 degrees, the degrees are going to cancel out, and I'm going to have 30 pi over 180. But we need to simplify that. And you can simplify that because you know your fractions, right? And you say, oh, you know what? 30 goes into 30 once, and 30 goes into 186 times, and this would give me pi over 6. Now, some of you out there are saying, oh, I hate fractions. I hate simplifying fractions. All right, if that's you, see that 30 pi over 180? You're going to go to your calculator. Let's put in a new page just so we have a separate page for this new thing. I'm going to use a fraction template. I'm going to put 30 over 180 without my pi. If I hit enter, it reduces my fraction to 1/6. And all I have to do is remember to put pi back in the top. So it reduces it to 1/6, and I have to remember to put pi back in the top. I now have my angle in radian measure. So 315 degrees, we multiply by pi radians over 180 degrees. So that's 315 pi over 180. And if you hate simplifying, you go to your calculator and you say 315 over 180 and you hit enter. Oh, 7/4. So that means we would have 7, put the pi back in the top, over 4 radians. So 315 degrees is 7 pi over 4. One more thing that we want to look at, and that's going the other way. If we have our angle measure already in radians, how do we change it to degrees? Well, it's a very similar process. We still multiply by 1, but we're multiplying this time by 180 degrees over pi radians. So 5 pi over 6, we would multiply by 180 degrees over pi. And a lot of kids remember this one easier because you look at this and you say, oh yeah, I want the pi's to be able to cancel out when I get my answer. So usually that's the one that you can remember a little better. So now we have 5 times 180 degrees over 6. So we go get our calculator again. It's 5 times 180 degrees divided by 6. That's going to give me 150 degrees. And I'm going to warn you, if you do not put a degree symbol on this, it's wrong. Anytime you have an angle and degree measure, you have to actually write the degree symbol. Otherwise, it means 150 radians. So now if we want 11 pi over 6 radians in degrees, we multiply again by 180 degrees over pi. Those pi's are going to cancel out. Now what we have is 11 times 180 degrees all over 6. So get that handy dandy calculator or do the arithmetic in your head. Okay, if you can do the arithmetic in your head, awesome. I'm all for that. Okay, so 11 times 180, and then we're going to divide by 6, and that's going to give us 330, but don't forget, that is in degrees, so don't forget that degree symbol. Now, look at number 3. There's no pi. When I multiply by 180 degrees over pi, there's no pi to cancel out with. And I'm going to be honest with you here. We're going to have to round this one. Okay? We're going to have to round, let's say, to 3 digits after the decimal. Okay? And we'll have to tell you what we want you to round to. So for this problem, I want you to round to 3 digits after the decimal. What you do is you actually type it all in the calculator. Negative 3.5 times 180 divided by, since it didn't cancel out, you have to divide by the pi. And there it is, negative 200.535 degrees. So this becomes negative 200.535 degrees. Isn't that marvelous? All right, one more last problem, negative 5.2 pi. We multiply by 180 degrees over pi radians because we want to end on a nice positive note where our pi's cancel out. We now have negative 5.2 times 180 degrees, and that's going to give us negative 5.2 times 180 degrees. There it is, negative 936. And what can't we forget? The degree symbol. All right, guys, awesome. All right, so we'll practice more of this tomorrow. See you soon. Bye.